3 down, 4 to the right. Or it can be written, that can be shortened down to 3d4. Or it can be used as a vector, which I much prefer. And that vector would look like this. That is a vector. Now the vector has a very specific order. This is referring to the x-axis, and this is referring to the y-axis. So x-axis then is left or right, and this is down or up, with left being negative, right being positive, down being negative, and up being positive. So we got this two-numbered vector, which is a direction and a distance. So whatever it is, if I'm ever moving any of these shapes, I think about the vertices or the corners of the shapes. So that's a vertex, which is a corner of the shape, plural vertices. And I want to move each one 4 to the right. So 1, 2, 3, 4, and then 3 down. So I do this, so you can do it easier because you've got your paper that has the squares on it. So 1, 2, 3, 4, and down. So something like this would be our translation. And now if something has been transformed, a transformation, it is no longer A, it is A what? With a little dash on it, yeah. A with a little dash on it. So that's a reminder of what a translation is. Now reflections are now going to take place on, well, some of them will take place on this coordinate diagram or Cartesian plane that we have just looked at. So reflections now, I'm going to do a question here. I'm going to do it in parts. First of all, we want to draw a triangle. Minus 3, 1, minus 1, 1, and let's go minus 3, 4. And I want to draw these 3 points on it. So if we have coordinates, so we have a Cartesian plane, we need to draw those on a Cartesian plane now. We need to, it is no longer just randomly in our book. We have a very specific spot we need to put it. So I will draw my Cartesian plane here. 1, 2. I'm just going to go up to 5 in each direction. Okay. So this is my y-axis. This is my x-axis. They go on forever, but I've just created a section of them here. All right, so now I'm going to plot the points or draw the points on and form a triangle, hopefully. Minus 3, 1, so minus 3 on the x-axis is here. 1 is up, okay, so it's here, around here, yeah? In 1 and minus 3. Minus 1, 1, minus 1 is here, up 1, that's around here. And we got minus 3, 4, which is up here-ish. So I'm in line with 4. Okay, so I have my triangle. So that is my triangle. So I've drawn each of these points. That's not the question though. I'm going to ask to reflect this. Draw a triangle, that, and reflect it. That's mirror line. Reflected in the mirror line x equal 1. So now I need to draw the mirror in a very specific point, this line, and I want to reflect. So x equal to 1, is that a vertical line or a horizontal line?
No, vertical.
Yes, because it's got to go through the x-axis at 1, so it's a vertical line. Here is my, whoa, slightly diagonal mirror line. X equal to 1, it's a line through x equal to 1. All right, Now I have to put this triangle looking at itself in the mirror, and somewhere over here is going to be my image. It looks at itself in the mirror directly, and somewhere over the other side is the image. So with this, I always go point by point. I don't try to do it all at once. It's a bit tricky to do it all at once. This point is 2 boxes away from the mirror, so its image is also 2 boxes away, looking directly at it.
I thought it would be 3.
It's maybe my scale is a bit weird, but it's definitely only 2. My scale is dodgy because I don't have a ruler here that's big enough. This one is 4 boxes away from the mirror. So if you count them, 1, 2, 3, 4 away. So its buddy's going to be 4 away on the other side. Now I haven't drawn a large enough Cartesian plane. That was on me. See, I needed to go up to 7, like the last one. 6 and 7. Anyway. Or did I? I don't know. But let's have a look. I think I need to go up to 5, not 7. So let's do that again. So we are 4 boxes. So this fella has to be 4 boxes away as well. 1, 2, 3, 4. Only up to 5. Oh, wrong color. Here. So that was 4 away. So this one, now let's count the boxes. You can count them here in the end. That's 1, 2, 3, 4. So its buddy must be 1, 2, 3, 4 away. And that's somewhere here. It should be in line. And there it is. There's my 3 corners or 3 vertices. Join them up, and I should have a reflected shape. Now, it looks a bit weird in mine because my scale is very dodgy. But it looks like it would fold perfectly over this line. Not perfectly, but if it was done perfectly, it would fold over that line and land on top of each other. So that's the kind of reflections we're now going to be doing, where we draw them on a Cartesian plane. And you could write in these points. So some lines that they use for reflections, if it was this one, x equal to 1, if that line was right on the y-axis, what's that called again?
Y equals 1.
No, x equals 0 is this line, remember. They usually don't say reflect it in the y-axis. They say it in the line x equals 0, which is a bit of a tricky one. All right, time for you to get on to the classwork and or my maths. Up to you which one you do. Both are going to be due on Thursday, so get on that.
Why do you